Hello everyone, I welcome you all to today's session wherein we will be discussing the continuation of the numbers discussion that we have been having in the previous 7 sessions. So, this is the 8th lecture, and in this lecture we will be continuing with the LCM models that we have covered in the previous class, and we will cover the HCF models also. So, basically some problems based on LCM and HCF models. So, in the previous video we have covered 2 LCM models. So, we will continue with the third model now, model 3 of LCM. So, just to recap, model 1 was when in the problem you note that the positive remainders are equal. Model 2 was when you note that the negative remainders are equal. Now, model 3 will be the case when neither the positive nor the negative remainders are equal. So, as an example, say the question is find the largest 3-digit number which leaves remainders of 2, 4 and 7, 2, 4, 7, just a minute. Or let me also just a minute, instead of saying largest 3-digit, let me change this also. Let us take find the smallest 4-digit number, let us take it this way, which leaves a remainder of 5, which leaves a remainder of 1 and which leaves a remainder of, let us take some number, let us say 2 when divided by 6, 8 and 3 respectively. So, we want to find the least 4-digit number which satisfies this condition. Now, if you look at this problem, it should be evident that this is not LCM model 1 because the 3 remainders are different. This is not even model 2 because if you look at the negative remainders too, here in this case the negative remainder will be 5 minus 6 minus 1. Here it is going to be 1 minus 8 minus 7, it is going to be something else, they are not equal. So, here in this problem neither the negative nor the positive remainders are equal, so thus it will be qualified as model 3 problem, LCM model 3 problem. Let us see how can we answer that. So, for answering it, I will go for a process. We do not have a formula as such, right, for this problem, model 3 problems. So, what we do here is, let us say the number that we are looking for is n. So, when n is divided by 6, by 8 and by 3, the remainders are 5, 1 and 2, okay. So, these are the divisors, these are the remainders. Now, if you notice, if you look at the first division and the third division, only that, ignore the middle one. Here, the positive remainder is 5 and positive remainder is 2, they are not equal. However, if you look at negative remainders, it is minus 1, 5 minus 6, it is also minus 1, 2 minus 3. So, can I say in the first and the third case, the negative remainders are equal? So, we may use LCM model 2 as far as the first and the third case is concerned. Let us use that. So, if I use LCM model 1, so can I say the number n will be equal to k into LCM of the divisors plus common remainder minus 1. So, please note I am only combining this and this. So, it is going to be LCM of these two is 6k minus 1, it is going to be 6k minus 1. So, that means by combining these two, I could write the situation as, so a number which when divided by 6 gives you 5 remainder and when divided by 3 gives you 2 remainder is a number which gives you remainder of 5 when you divide by 6. So, basically combination of these two is nothing but this, please note. So what I am saying is, if you take a number like 6k plus 5, so divisor into quotient plus remainder, let us say you take this, you divide this by 3, see what do you get. So when you divide this by 3, this will give you 0 remainder because 6 is a multiple of 3, 5 by 3 will give you 2 remainder, and hence my remainder is definitely going to be 2. So if you combine these two, it is going to be this condition only, 6 and 5 condition only, and the other case is 8 and 1. So we can ignore the third case entirely, we can ignore that. So now we are left with only 2 cases. So here can I write the number n as divisor into quotient, say k1 plus remainder. Here can we write it as divisor into quotient, let us say k2 plus remainder. So these two should be equal. So if I put them equal, let us see what happens. So can I write 8k2 minus 6k1 should be equal to 5 minus 1, which is 4. We can cancel out the common factor 2 on both sides. So when you cancel out 2, it will be 4k2 minus 3k1 will be equal to 2. So 4k2 minus 3k1, let us take it on the other slide. So by hit and trial, can I say the value of k1, k2 can be the minimum values will be 2 and 2 each, because if I put both of them as 1 each, then the difference I will get is 1, 4 minus 3, 1. So hence I need to put them as 2 each, so that the difference can be 2. So this is a least value. So k1 least value is 2. So that means the least value of n that I will get is, put k1 equal to 2 here. So when you put k1 equal to 2, you will get 6 into 2 plus 5, which is what? 17. So the least value that we have for n is 17, but the question is not about least value. The question is about least 4-digit number. So how do we get to that? So from least value, if you want to find the general form value, the method is this: some constant k, or since we have used k already here, let us use some other constant. Let us put the constant as some maybe a into LCM of divisors. What are the divisors that we have? 6, 8, 3, or simply 6, 8 plus the least value. So how much will this be? LCM of 6 and 8 is 24. So 24a plus 17. So this is the value, general value for n. But since I want 4-digit number, I need to put an appropriate value for a there. Let us see what can we put. A equal to 40 if I put. So the value of n that I will get is 24 into 40 is 960. 960 plus 17 is 977. There is scope to go higher. Put a equal to 41. If I put 41, what do we get here? 960, 960, 984 plus 17 is 1001. And can I say this is like the second smallest 4-digit number that we have. So the question was smallest 4-digit number. My answer will be 1001. So thus, for this question, after this entire working out, my answer will be 1001. There is no direct formula for model 3 problems. This is the only way in which you have to work out. So basically, you will have to make use of the division rule for these model 3 problems. I hope we are clear with this. Now, let us look at the HCF models. Let us start with model 1, HCF model 1. So HCF and LCM, there is a basic difference that we have in the two terminology itself. In case of LCM, we are talking about multiple, least common multiple. HCF, of course, we are talking about factors. So there would also be one more difference with respect to problems based on LCM models and HCF models. So far, if you recall, in our LCM models, always he was asking us to find the dividend, find the smallest number which would do this. So we are finding out n, capital N, which is dividend. In HCF problems, the overall approach of solving the question will change now, because we will not be solving for the dividend anymore, we will be solving for the divisor, the factor, and hence the HCF model. I will just give you an example question wise. So let us say the question is something like this: what is the greatest number that divides 389, 576 and let's say 430, leaving respective remainders of 9, 6 and 5. So this is the question. So we want to find the greatest number that divides these. So when I say number dividing this, so A divides B means what? A is a factor of B. So here we want a number which will be dividing these numbers. So these are the dividends and we are looking for divisor this time. The question is all about finding the divisor. So that's one stark difference that we have between the LCM models and HCF model problems. As I was saying some time back, LCM model problems will ask you to find the dividend values, find the number n. Here the question is about, if you understand it clearly, it's about finding the divisor, the greatest divisor actually. The greatest number means greatest divisor. Let's try to understand. So let's say the number is n or some d. Let the number required be d. So if this d divides 389 and leaves a remainder of 9, that means can I say something like this, just to extend the process, 389 divided by d, some quotient will give you remainder of 9. Okay. So can we say based on this division, 389 minus 9, so basically dividend minus the remainder must be a multiple of d, we can say that, must be a multiple of d. Similarly 576 minus 6 must be a multiple of d, and likewise 430 minus 5 should also be a multiple of d. Also note, if I can say that A is a multiple of B, means can I say B will be a factor of A? So thus if 389 minus 9 is a multiple of D, this implies D must be factor of 389 minus 9. Similarly, D must be a factor of 576 minus 6, and likewise 430 minus 5. So D should be a factor of this also, second number also, third number also. Basically, can I say D is a common factor? So common factor of these three. Also, I want D to be greatest. So that means D should be the greatest common factor, or GCF or GCD or HCF. Hence, can I say D will be equal to HCF of 389 minus 9, 380. 576 minus 6, 570, and this is 425. So let's see what do we get here. So I'll just do it on the next slide. 380, 570, 425. So 380 is nothing but 190 into 2, which is nothing but 85 into 190 into 2, right? 85. 1 second, 95 rather, not 85. It's 95 into 4. Right? What about this? This is 190 into 3 or 95 into 6. And this is 425, which will be what? 85 into 5. So let's see what's the common factor that we can search for. So 5 into 19 into 4. Here it's 5 into 19 into 6. Here it's 5 into 17 into 5. Now we don't see any common factor except for 5. But that's not really possible because we are talking about remainders of 5, 6 and 9. So let me change the question slightly, little bit, alright. So instead of 430, say we take probably something like 460 here. Let's see what do we get if I take 460. So I'll just change it everywhere. and the idea is only to 455 to get an appropriate answer. That's the idea. So if I take 455 here, it will be 95 into 5, right? No, not even this. So sorry, one second. We'll have to change it further. So let me take this as 480 instead. 480. Let me just change it everywhere. So if I take 480, leaving remainder of 5 will be 480 minus 5, 480 minus 5, and this is 475. Now it will be okay, I think. Just observe this now. This is 475. So 95 into 5, which is 5 into 19 into 5 into 5. Now if you look at it, the HCF happens to be 5 into 19 everywhere. So thus the value of D, which is nothing but the HCF of these three numbers, will be 5 into 19, which is 95. This is by the regular process without using any formula as such. But there is a formula that we can actually make note of. So I'll just write down the statement here. The greatest number that divides P, Q and R, leaving remainders of A, B and C respectively, will be equal to HCF of P minus A, Q minus B, R minus C. So this formula may be used to get to our answer directly, and this is what we did finally. If you notice, we got to this HCF of P minus A, Q minus B, R minus C. So same formula can be written like we could directly get to this step instead of going for all these unnecessary extra explanations that we have done. No need to go for all this in the exam. In the exam, we can straight away write this step. So this is your HCF model 1. Now, similar to this, let's take up quickly HCF model 2. Now, without actually explaining it by the basic process, let me straight away share the identifier and the formula. How do we identify it's a model 2? Model 1 identifier was remainders are different. Model 2 identifier is remainders will be equal. So the statement goes like this: the greatest number that divides P, Q and R, leaving the same remainder in each case, will be HCF of, will be equal to, will be HCF of, let's assume P is greater than Q is greater than R for the sake of discussion. HCF of, you take pairwise differences, so P minus Q and maybe Q minus R, that's it. So this is going to give us the answer in case of HCF model 2. A similar statement that we have written for model 1, we could also write it for model 2. The difference is, in model 2, remainder should be all equal. In model 1, they should be different. Only then P minus A, Q minus B will make sense. Here they are all equal. So thus there is no role of the remainder in the final answer. There is no role of the remainder at all. Okay, and example, you can take any random values for P, Q, R and just check it, and it's only application of the formula now that I have shared the formula. So that's it. With this, we have come to the end of the session today. I hope you followed it. Please do regularly visit the channel, right? Solve some more questions from the that we'll be sharing on the same channel, right? On that note, let me end the session here. Thank you and all the very best.